Hello Savers, today we're going to look at section 4.6, which is on formalizing relations and functions. So what this means is we're actually going to give what we've been going up to. This is the summit section. So this is what sections 4.1 through 4.5 have been leading up to. So you're going to want to have a notebook, a pencil, and then a calculator. So this video is going to focus on how to determine whether a relation is a function, find the domain and range of a function, and use function notation to find values. Now, a lot of this should look like review. But first, some vocab. Domain and range. We haven't talked and used those words exactly. But domain is your input. So this is the input values, which most of the time we'll call these x values. So your domain is always your x values of the function. So we're always going to want to find our x values for domain. So dx. Now our range, if you can guess, that's our output values, which our output values are commonly named our y values of the function. So we're going to normally consider dx our y. So let's take a look at problem 1, which is on identifying functions using mapping diagrams. So we need to identify the domain and range and then represent the relation with a mapping diagram. So a relation is just x's and y's paired together. So we need to then say, is the relation a function? So let's first identify my domain, which I'm going to say capital D, and my range. Now, I said my domain is the x value. So my domain is -2, 0, 4, and 5. Now, my range is my y value. So that's, if I put my curly brace here, 0.5, 2.5, 6.5, and 2.5. Now, since I already have a 2.5 in my range, I do not need to write him a second time. Alright? So now, I need to then represent using a mapping diagram. So mapping diagrams look something like this. You're going to make two bubbles right beside each other. Now, you're going to label one bubble as an x and one bubble as a y. Now, all your domain values are going to go in the x bubble. So my domain is -2, 0, 4, and 5. And then your y bubble is going to contain your range. So I got 0.5, 2.5, and 6.5. Now, what you're going to want to do is point arrows to the numbers that relate. So -2 was related to 0.5. So I'm going to draw an arrow saying -2 goes to 0.5. Now 0 went to 2.5. Where I'm getting this from is my numbers up here, because I had 0 and 2.5 were together. Now 4 went to 6.5, so he went down there. And then I said 5 was to 2.5, so he's going to cross over, and he's going to go there also. He's going to go to 2.5, which is probably better if I went like that. There we go. Looks a little better that way. Now, to know if I have a function based on my diagram, you're going to want to see, do I have two arrows coming off of one x? So if I notice here, I have only one arrow, one arrow, one arrow, and one arrow. That means, yes, I do have a function. We cannot have two arrows coming off the same x. Otherwise, if I plug in, let's say, 3, and I don't have two arrows, how do I know what number I'm going to get? I don't. I want to know what value. If I put in a -2, I want to know always I'm going to get 0.5. So that is what a mapping diagram allows us to do. So let's look at this part. We want to say D equals, so I'm going to find my domain and range, just like I did over here. Put a curly brace. My domain is my x values here. So I got 6, a 4, oh, got another 6, don't need to write him, 5. Now my range, I have a 5, a 3, a 4, and an 8. So now I'm going to draw my mapping diagram again. So I got 2 bubbles, I got an X over here and a Y over here. So my X values are 6, 4, and 5. And my range is 5, 3, 4, and 8. So now 6 went to 5. So I'm going to draw an arrow from 6 and I'm going to point to 5. 4 went to 3. 6 went to 4. So I'm going to cross over and point there. And then 5 went to 8. So I'm going to go straight across. Now, if you notice, I have 2 arrows, 1 and 2, coming off of 6. That can't happen. He is not a function. He can only have 1 arrow at most coming off of him. If he has 2, if there's 2 x's or 1 x with 2 arrows, that means I cannot have a function. So, no x can have more than 1 arrow. That is basically what I'm trying to get at. No x can have more than 1 arrow. Otherwise, I don't have a function. Now, the vertical line test. This is a way to look geometrically and not algebraically to see if you have a function. So, we're going to first want to plot these points. I have -4, 2. So, -4 and a +2. Got a dot there. -3, 1. So, I have -3, 1. Put a dot there. 0, -2. That's kind of a silly dot right there. -4, -1. So, I got -4, -1. That's a dot right there. And 1, 2. 1, 2. Right there. So, now, the vertical line test says, if I draw a line anywhere, and I mean anywhere, it needs to be a vertical line, hence the name, I cannot hit more than 1 point. So if I start drawing some vertical lines here, well, that's not very vertical, but I'm not going to hit more than 1 point there. Put a line through here, I'm only going to hit that point. That's okay. What about right here? Nope, that's only 1 point. But if I draw a line right here, do you notice how I hit this point right here? And I hit that point? I can't have that. That says it failed the vertical line test. He got an F. So that means if he gets an F, that means he's not a function. Now, let's look at B. Y equals -x² + 3. So I have graphed this function. It looks something like this. It's a parabola upside down. Its tip top is at 3. So we're going to want to see, can I draw a line anywhere on this graph? And it needs to be vertical. Can I hit this graph more than once? So I'm going to start kind of drawing some vertical lines here and see. I only hit once there. Only hit once there. Only there, too. Only once there. Only once there. So if I look here, am I ever going to hit more than once? No, I'm not. It's going to stay. I'm always going to hit that once. So this guy passes. He gets an A+ on the vertical line test. So if he passes the test, that means he is, in fact, a function. Now, evaluating a function. A lot of you probably have seen this notation, but it's never been explained to you. The function w of x. This is how you read that. You go w of x. So letter outside of letter inside equals 250x. This represents the number of words w of x you can read in x minutes. How many words can you read in 8 minutes? Now, w of x is just a really fancy way of saying y. It's saying if I plug in x into a function named w, this is the name of my function. My function's name is w. If I plug in or substitute x, what am I going to get back out? Which is my y. So this one's saying W of x equals 250x. They want to know, what if x is 8 minutes? So what if I say x is 8 minutes? So I'm going to plug in, for my x, I'm going to say 8. So I'm going to say W of 8. So what this is saying is, into W, please plug in an 8. So I'm going to do that. So I have 250 times 8. I saw an x, I need to put an 8. So now this side over here, we just kind of ignore it. It's just notation over there. We can't do anything there. So we got 250 times 8, which is 2,000. So we know that into W, if I plug in 8, I get 2,000. Now, what does that mean in this problem? They wanted to say, how many words can I read? So I can read 2,000 words in 8 minutes. That's pretty amazing. Now, finding the range of a function. This is not too bad. The domain of f of x equals negative 1.5x plus 4, and that is 1, 2, 3, and 4. That's the domain. They want to say, what's the range? So let's put this in easy terms. Domain, they're saying the x values. If you remember, that's what domain is. So the x values of this function is 1, 2, 3, and 4. What is the range? Now, range is code word for y values. So I'm going to create an xy chart. And I'm going to put my x values, my domain. And they said that was 1, 2, 3, and 4. Now, they're saying, what are my y values? So if I take this and I plug these into my function, what am I going to get back out? So I'm going to go negative 1.5 times 1 plus 4. So I'm going to actually do that on my calculator, and I get 2.5. 2, I have 1.5 times 2 plus 4. So wherever I saw an x, I plugged in a 2, and I got 1 once I did that on my calculator. So I want you to try number 3 and 4, try to plug those in, see what you get. Alright, so you should have tried to plug those in. So I got negative 1.5 times 3 plus 4. And you should have gotten negative 0.5 or negative 1/2 is the same idea. And then if I plug in a 4, you should have gotten a negative 2. So my range is the following values. 2.5, 1, negative 0.5, and negative 2. That's all they're asking for that problem. Just kind of a little wordy in a way. And the last problem we're going to look at, which is on identifying a reasonable domain and range. You have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 feet squared. The function a of q equals 100q represents the area a of q in square feet that q quarts of paint cover. What domain and range are reasonable for the function? Now, we're actually not going to graph this one because you guys have been practicing graphing quite a bit. So we're just going to find the table that we would use to graph. So they want to know what's the reasonable amount. Now, reasonable means realistic in a way. So the best way to find it is what's the lowest x and what's my highest x. So I'm going to create an xy chart here. And I'm going to want to find who's my lowest x. So my x, or my q in this case, is the quarts of paint. So the least amount of quarts of paint I can use is 0, right? I just won't paint it all. So my lowest x is 0. Now my highest x, how much paint do I have to use? I have 3 quarts of paint. I don't have 4 quarts, I have 3 quarts. So the highest amount I can use is 3. Now, they say if I plug in Q into this equation, I'll get the area. So the area is my Y. So this is going to be the lowest Y value I can have. And this is going to be the highest Y value I can have. Now, if I plug in 0 into 100 at Q, I'm going to get 0. I'm going to get 0 coverage of paint. which really makes sense, doesn't it? And now I need to find the highest y value. So I found my highest x was 3. And I want to see, what if I plug in 3 into my formula here? So if I plug in 3 for q, I'm going to get 100 times 3, which is 300. So I'm going to get 300 square feet of coverage. Now, what this allows me to do is I can now pick some x values that go between 0 and 3. So I could pick 1 and I could pick 2. Then I can get the relational y values to that. So if I plug in 1, I would get 100 times 1, which is 100, and 100 times 2, which is 200. So what this allows me to do is create a graph that's realistic and has points that make sense. See you later, Sabers.